Here we would like to find the common ratio for each geometric sequence here, and also we want to find the sum of all terms of this any given geometric sequence. So the sum of all terms, there's a rule for that, of course. We have to check that the common ratio, the absolute value of the common ratio, is less than 1. If it is, then we can find the sum of all possible terms. As you can see, this is the infinity sign, because you're going to take the infinitely many terms of a given sequence and you're going to find the sum of all of these terms, right? So you're going to add them up all together, infinitely many terms in each of these sequences, and you're going to find the sum of all of these terms. So first we have to find the common ratio to see that we satisfy the condition that the absolute value of it is less than 1. So the common ratio, of course, is going to be what here? It's going to be 1/2 divided by 4. Right? Because we know that 4 times the common ratio should give us the next term. So 1/2 divided by the preceding term should give us the common ratio. So 1/2 divided by 4 is the same thing as multiplying the reciprocal of it, which is 1/4. So that's going to give us 1/8. So now the condition is satisfied, right? Because the absolute value of 1/8 is 1/8, and this is indeed less than 1. So we can find the sum of all terms of this sequence. So it's going to be what? A1 is the first term, so that's going to be 4 divided by 1 minus the common ratio, which is 1/8. So this should give us what? 4 divided by 8/8 minus 1/8 is 7/8. Of course, so that means 8 will multiply to 4, so we get 32 sevenths. Okay, so the sum in this case is not undefined. It is going to be 32 sevenths. The next example, of course, think about the functionality of this when it comes to finding the infinite sum of all the terms. In this case, notice that it always fluctuates. It goes 1/5, then -1/5, again positive, the next one will be negative, etc. How can you possibly add infinitely many times and expect to get a value something like that, or another value? There won't be a value, because if you add 2 of them, you get 0. If you add these 2, you get 0. Right? If you add these 3, you're going to get 1/5. Right? Because this gives you 0, but then you add another 1/5, you get 1/5. So how do you know when to stop? You don't, right? So naturally it should be undefined. But let's check that using the rules so that we can prove that this sequence cannot be defined as in terms of giving the sum of all terms, right? So let's find the common ratio. The common ratio is going to be -1/5 divided by this 1/5. As you can see, it's just -1, but let's test that. It's going to be times the flip version. 1/5 flipping is 5/1. I just wrote it as a 5. 5's cancel out, -1. Bingo. Now notice, if we check the condition, absolute value, -1, right? Because that's the common ratio, is equal to 1. But that is not less than 1, right? 1 is not less than itself, right? So that is not true. So since this condition is not satisfied because the common ratio, the absolute value of the common ratio is not less than 1, you can say safely that this is undefined. So we can say sum of all terms in the sequence is undefined. And again, because this condition was failed. Now this one, the common ratio is -12 divided by the preceding term, which is -1/3. Now let's check the condition. The absolute value of that is 1/3. 1/3 is indeed less than 1. Good. So we can safely find the sum of all possible, the greatest number of terms, infinitely many terms in the sequence. So it's going to be the first term, which is 36, divided by 1 minus the common ratio of -1/3. Be sure that you include -1/3 and not positive. We got positive because we were checking the condition of the absolute value, but make sure you don't put this one because it's going to give you a wrong answer. This is the common ratio. It's negative 1/3, right? So I might as well just put semicolon there. Negative 1/3. So that should give you 36 divided by, this is 3/3 plus 1/3. So that's 4/3. So as you can see, 3 will multiply the 36, but let's divide 36 by 4, we get 9. 9 times 3 is indeed 27. Okay? So here we were successful. The sum of all terms in the sequence is 27. Now finally here, 0.95 divided by 1 is 0.95. And as you can see, 0.95 inside the absolute value bars is equal to 0.95. And that's indeed less than 1, barely less than 1, but still less than 1. So we can find the sum of all terms, infinitely many terms, is defined. Right? So the first term is 1 divided by, using this formula, 1 minus 0.95. So this should give you what? This should give you 1 over 0.05. Okay? And that's the same thing as 1 over 5/100ths. So that should give you 100 over 5, which is equal to 20. All right? So we found indeed that the sum of all terms in this sequence was equal to 20. So I hope this tutorial was fun and useful. Thanks for watching, and see you in the next video.